All right. And yeah, so welcome everyone to the Stacks Signer Workshop. It's April 3rd, 2024, and really excited for this workshop today. Thank you all for joining. I know it's been about a week since we first released the Nakamoto testnet, and a lot of folks on this call have been really busy providing really good feedback for us, working to get the signer started. So we appreciate you being in the trenches with us, getting this started. And we wanted to schedule this workshop really as a way to just one, go over some technical details, really try to help you all get started, maybe work through any issues that you have in the setup. We'll have a chance for a Q&A, and you can ask questions with some of the core engineers that we have here. And also it's a chance for us to get feedback, and we'd love to hear more about how the signer has been working for you all so far, and things that we can do differently or better as we move towards the mainnet release. So with that said, let's go ahead and get started. So I will be presenting just for a couple of minutes here. I'll give a quick overview of the Stack Signer, and I'll just briefly go over some details on the Nakamoto rollout and timeline, just so everyone here is on the same page. And then I'll turn it over to Kenny for a live demo of some of the stacking flows and configuration options. And we'll try to save plenty of time at the end for a Q&A. Okay, so to get things started at a high level, Stacks enables decentralized and scalable Bitcoin applications. The goal is really to make Bitcoin a productive asset and enable new use cases like DeFi and ordinals trading, things like that on the layer 2. The Nakamoto upgrade is a pretty key change for how the Stacks network operates. The three main things that you all need to keep in mind when you hear the Nakamoto upgrade is that it enables faster blocks. So it'll reduce the Stacks blocks times down an order of magnitude to around 5 to 10 seconds. Bitcoin finality, so Stacks will receive 100% of Bitcoin's security budget and will no longer fork on its own. And lastly, it implements new signer rules, which of course is why you all are here today. So after the Nakamoto launch, Stack signers, which we also refer to them as validators, we use those terms interchangeably. They will actively participate on the protocol by signing and validating new Stacks blocks. And when SBTC launches, they'll have a role in signing and validating SBTC mint and redeem transactions. And SBTC will go live in a separate upgrade that's expected in summer of 2024. And so far, we already have 20 plus signers that have publicly been confirmed to support the Nakamoto launch. This is a mix of many institutional validators as well as more solo indie validators as well. This is just the first step. I'd expect that we have around 30 around mainnet launch, but the ultimate vision is to eventually scale this to be able to support hundreds of signers in the future. And so this is really the first step for that. And I just wanted to go over quickly some details on the Nakamoto rollout that are relevant for this group. I think the main things that you all should be aware of are that the Nakamoto upgrade is happening in two primary phases. So we can look at these bullets 5 and 6, where the first step is this instantiation phase, where the POX4 contracts are deployed on the Stacks network. But the rules haven't taken effect yet. So it basically means that signers can begin onboarding and registering for Nakamoto, but without actually contributing to consensus yet. This is basically just an onboarding phase. And then the activation period is scheduled to take place in mid to late May. This is basically, will include all the features that I just spoke about in the last slide, including fast blocks, Bitcoin finality, and all of the new signer features as well will be included in this. And to go just a little bit deeper, so we've scheduled a series of testnet releases over the next 2 months. And I know it can be a little bit confusing, so I just wanted to go over a little bit about what you can expect with this in this chart. And we can send around this chart at the end of the meeting, or it might already be in the docs. If not, Kenny, we can get that added there. But here's some of the main details for you all. So last Monday, we released the Nakamoto 2.5 Nakamoto testnet with Epic 2.5. This basically enables the open signer network, so signers can begin onboarding, but it didn't include all of the features around fast blocks and Bitcoin finality. And then a few days later, towards the end of last week, we actually merged this into the primary mainline stacks testnet. So it basically means that this primary stacks testnet is is enabled with all of the signers can join the mainline stacks testnet. But again, this is Epic 2.5, and the full Nakamoto rules haven't yet taken effect. Quick note that I think several people have already started onboarding onto the Nakamoto testnet. Moving forward, we are recommending that people use the primary testnet, since this will be since this is now the most up to date with all of the latest features. And then when we look towards the next couple of months, just wanted to give a quick rundown of what you all should be able to expect. So by mid-April, in approximately 10 days, we'll have basically the Nakamoto testnet on Epic 3.0. So this will include not just the signer rules, but as well as fast blocks and Bitcoin finality. And then in mid to late April, we'll have the mainnet instantiation phase. So again, this activates Epic 2.5 on mainnet, and it basically means that signers can begin onboarding during this phase. And then in mid to late April, probably around the same time or shortly thereafter, we will merge the 3.0 rules onto the primary testnet so that signers can basically start testing the Epic 3.0 on the mainline stacks testnet. And this is the last step to note before basically before the mainnet activation, which again is scheduled for that mid to late May, and that'll include actually signing blocks as part of consensus, as well as the fast blocks and Bitcoin finality for these Nakamoto rules. So I know that's kind of a lot of information there, but just wanted to give you all a good sense for what this rollout will entail and what you should expect from the different test networks that we have planned. And I'm sure Kenny will go into more details on all of this during his live tutorial. So with that out the way, I'll maybe turn it over to Kenny to begin his demo. So yeah, Kenny, let me make it so that you can share your screen, which you should have now, and feel free to take it away.
Cool. Yeah, thanks, Andre. Real quick, before I share my screen, just kind of want to go over a little bit of an overview of what we're going to talk about today. There's a few things I want to do. One is I want to just quickly go over the process for setting up and running a signer and a stacks node side by side. So we'll walk through the process for doing that with Docker. I'll spin up a signer live on the call, and then we'll go over some of the config options and some of the common logs that you might see. So you can kind of know, okay, what does it mean if it says this? Does that mean my signer is running? Is it not running? How do I know if it's running? All that kind of stuff. And then after we kind of run through the signer setup, then we'll switch gears and cover the stacking flow. And we'll talk about how, like, what the different stages are between running a signer and stacking, and how those cooperate together to actually spin up a functioning signer. And then after we go through the demo part of it, we'll jump over into a Q&A portion, so that any questions that you have that didn't get addressed during the live part, you can ask after that. And then last thing, if Hank or any of the other core engineers on the call hear me say anything incorrect during this live demo, just interrupt me and just correct me right there on the call. That's totally fine. So first thing I want to do, I will share my screen. And we'll jump into the docs. So basic high-level process for what you need to do when you run a signer is you're going to need to run a signer and a stacks node side by side, and those are going to have a two-way communication where the signer's going to be listening for events from the stacks node and vice versa. So we need to get these up and running next side by side and communicating with each other. And specifically, the kind of stacks node you'll want to run as a testnet follower node. So these docs are being updated pretty much every day to try and make things a little bit more clear, add in some notes for different bugs you might run into. So as we kind of go further, these will start to improve more and more. And so the first thing you're going to need to do is just set up a new, generate a new private key for your signer. I've already done some of this before the call so that we don't have to go through too much of the boring stuff live. So I've already got a lot of this set up. And then what you're going to do is you're going to create a configuration file called signerconfig.toml. And I have a section in here that's sample configuration files, and we've got this signer right here. And so a few minutes ago, Andre mentioned that there's the Nakamoto testnet and the primary testnet. All of these are currently set up for you to be able to get up and running on the primary testnet, because that's where we recommend everybody get going from here on out. If for some reason you do need the Nakamoto testnet config, that's down here in the dropdown. But today we're going to cover the primary testnet configuration. So a few config options in the signer config file. First thing is the node host. And so this is just going to be where your Stacks node is going to be running. For the most part, as long as these are running on the same network, you should be able to keep the defaults for a lot of these. Network, testnet or mainnet, DB path. This is the path where your signer is actually going to persist data. Most of the time, you can keep this as the default. This is just any random string. This is an auth password that's going to allow your signer and Stacks node to communicate to each other. But this can be any random string. And then this is the Stacks private key that you generated in that previous step on the how to run a signer page where you generated that new keychain. That'll go right here. So you can, for the most part, just copy and paste this and replace these two things. Depending on your setup, you may need to change this node host and this endpoint, but that's really going to depend on your exact setup and how you're running everything. The important thing is that these two, the Stacks node and the signer, can communicate with each other. Then for the Stacks node, again, for the most part, you can copy and paste this. A couple things to pay attention to are this working directory. This is where you're going to want to set this to be the same place where you downloaded the chain state archive, and I'll go over that in just a second. And then the bootstrap node is the other important thing to pay attention to. This is the node that your node is going to connect with first to use to begin syncing chain state. And so this is what's going to change depending on whether you are spinning up a Nakamoto testnet node or a primary testnet node. So this bootstrap node is to connect to a primary testnet node. And then the other things you're going to want to change are right here under this connections options header, the block proposal token. This is going to match up with this auth password field that you created here. And again, that can be any random string. Usually, depending on your setup, you can leave this as default, but depending on what your setup is, you may need to change this again, just so your signer can communicate with your Stacks node. This is going to be the endpoint that's going to need to be accessible to that. But besides that, you can pretty much copy and paste these. We'll go back to the how to run a signer page. And in that config file, I mentioned an archive. And so I'm going to get to that in just a second. But the first thing I want to do is I want to get my signer up and running with Docker. So I'm going to copy this, open up my terminal, and I already have these config files created right here. I can actually remove this. I'm going to put this Docker command here. I do need to add one more field here for my setup specifically, because I'm running two isolated Docker instances on the same machine. I need these to be connected to the host network so that way they can communicate with each other. So I'm going to run that. And then if I run Docker PS, we can see the container ID here. I run these logs for that. And we see that the signer spawned successfully, waiting for messages to process. So this means that it worked. And now we just need to set up the Stacks node, because right now the signer doesn't have anything to communicate with. So normally what you would do here, if you were going to set up a Stacks node on the primary testnet, is you would start with an archive. And I have instructions for that right here in the docs. But basically what this means is that you can start with a testnet chain state snapshot so that you don't need to sync from Genesis, because the two options are you can spin up a fresh Stacks node and you'll have to wait quite a long time. I think I want to say 20 hours right now to sync from Genesis. But if you start with a snapshot, you'll have all of that state preloaded. And so instructions for doing that are right here. For the purposes of this demo, I'm not going to use that archive because I don't have enough room on my local machine. So I'm going to run it as if I was syncing from Genesis. But you will likely not need to do this depending on your setup. Probably
Kenny, sorry to interrupt. I have a quick question on that command. In the port, so 2433 you say, but in the config it says 2443, I believe. Is that wrong, or am I wrong? I don't know.
I think you're right on that. Yeah, great catch. 20443.
And that would be in this one,
The one right above.
The
Yeah.
first.
or 4-3. Cool.
443. Yeah.
Yep.
443,
excellent catch.
444. Yeah. Thank you.
Thank you for catching that. I'm taking notes as we go to make adjustments to the docs. So let me write that down real quick. Okay. Run that. Check the logs here. Okay. So a couple things to note here. There's a lot going on right here. The main thing that we want to check is that this registering an event observer at the endpoint that we passed in is here. All of these other messages and warnings are basically happening because we're starting from scratch. And so none of this stuff exists yet. So first it needs to sync these Bitcoin headers. This sortition DB doesn't exist yet. That needs to be created. So we're going to get that information. But what we really need to do is just wait for these Bitcoin headers to sync, and then we'll start getting some meaningful information after that. So I'm going to open up Docker desktop and open this up right here. We're not going to sit here and wait for these to run, so don't worry. But as long as you are seeing something like this with the registering event observer and then the Bitcoin headers are syncing, then you should be good to go. And then we can wait until those Bitcoin headers have finished syncing to see what the rest of the logs are and make sure everything's up and running correctly. But the logs are only going to be marginally useful until these Bitcoin headers have finished syncing. So with that said, I will make sure to adjust this command to put in the right port after this call. But once those are both running, the next thing you're going to want to do is you need to set up your Stacks accounts. So you need 2 accounts to operate as a signer. And I know this has been a point of confusion, so I'm going to try to really drive this point home about the clarification between these two. But pool operator, you need a pool operator wallet and a signer wallet. We already created the signer wallet in the first step up here when we did this pre-flight setup and generated the new private key with our CLI. So that generated our signer wallet. But then you also need a pool operator wallet. And you can set this up using Leather. You can set it up using the CLI like you just did. But the difference is that the signer wallet is the account that's going to operate your signer. Your pool operator wallet is going to be the account which you are going to initiate stacking transactions from. So those are the differences between the 2 accounts. So a lot of confusion was around the terminology of a signer. And so a signer can be a single entity that has a signer wallet and a pool operator wallet. And I've tried to make that distinction in the documentation to make it obvious which one we're talking about. It wasn't very clear before. I did a big rewrite yesterday to clear some of that up. But those are the differences, and we'll kind of see where the differences come in as we go through the stacking flow. But before we do that, I want to jump over to this FAQ page, because we have tried to add here, as we get reports of different error messages and different log messages, which ones are here and what they mean. And so depending on what your error is or what your log message is, you can go here and check out what it actually means. Some of them seem like errors, but they're not. And then some of them actually are errors. One of the big things you'll want to pay attention to are whether or not it's failing to communicate with another node. So that would be a message like peer not connected. And that's pretty normal. As long as you're able to connect to your Bootstrap node, then you should be good there. But if there's a connection refuse error or something along those lines, then that likely means that your signer and your Stacks node are failing to communicate, in which case you'll want to take a look at your endpoints to make sure those are configured correctly. But we have a bunch of these here to go through, and we'll continue to add those as we get more reports from signers. So, okay. Okay, so these still aren't quite done yet, but once these are done, this message that we got here about the signer being spawned successfully, once your Stacks node is up and running, this is going to change to basically saying that the signer is not registered for cycle X, so whatever the next upcoming cycle is. That means that at this point, your signer and your Stacks node are up and running, and now you just need to start stacking in order to actually register your signer. And so that's where this next part comes in. So before we run through the stacking flow, I want to cover a little bit what we mean when we were talking about reward cycles and prepare phase, because the timing of this can be important. So every stacking reward cycle begins with a prepare phase. And the prepare phase is where the signers are going to begin polling the stacking contract to see if they're registered as stackers or not, based on their public key. And so it's important to have your signer running and already have stacked before this prepare phase starts, because that's when your signer is actually going to be checking to see, am I actually a registered stacker or not? And if it's not, then it's not actually going to operate as a signer. It has to be registered as a stacker, and the signer has to be running. So it's important to do that before the prepare phase starts. The easiest way to check on the timing for that is to go to this endpoint in the Hero API, which is in the documentation if you need to check this, but it's the POX endpoint that gives you some information. And so if we look right here at current cycle ID, that is the reward cycle that we are currently in. And then the other important number to know is this blocks until prepare phase. So this means that there are 773 blocks until we start the prepare phase of the next reward cycle. So what you want to do as a signer and stacker is you want to make sure that your signer is running and operating correctly, and that you have stacked your stacks tokens before this prepare phase hits, because then once it hits, your signer is going to go and check the contract and see, okay, I'm registered, I need to actually start operating as a signer. And so that's sort of how the timing with the prepare phase and the reward cycles work. So quick recap of where we are in the flow of things now. We have a signer running and waiting to do its job, but right now it's not doing anything because we aren't stacking. We have a stacks node up and running. And so now the next thing we need to do is we need to actually start stacking before the next prepare phase. So remember in the documentation at the end of the how to run a signer docs, it said that we had to have two accounts, the pool operator and the signer account. What I want to do quickly is go over some of the definitions and roles that are involved in stacking, because I know we've had a little bit of confusion around that. I've tried to lay it out clearly here in the docs to separate them a little bit more. So we'll go over them right here, right now, real quick too. But a stacker is any entity that's locking their stacks to receive proof of transfer rewards. They don't necessarily have to run a signer, but they can. This is more of the generic term to basically describe anybody that is stacking their stacks, and they can do that in 3 different ways. They can do that as a solo stacker, a delegator, and then the third party in this sort of dynamic is the pool operator. So a solo stacker is somebody that's locking their own stacks and they're also running a signer. They don't receive any delegated stacks from anybody. A delegator is a stacker who locks their stacks tokens and delegates it to a signer, and they don't run their own signer. And then a pool operator is somebody that is running a signer and is accepting delegations from other stackers that want to stack their stacks through them. And then a signer refers to any entity that's running the signer software. But when we say signer, we're mostly referring to an entity, and that doesn't necessarily mean that it's the same address. Remember that a signer is an entity, and they can have a pool operator address and they can have a signer address, and those are going to be 2 separate things. So this guide is mostly focused on solo stacking and pool operator. Delegating is much simpler, and so there's a quick start guide over here for that. But because if you're delegating, you're not running a signer, that's not as relevant to the group here. So solo stacker flow, you have to have a minimum number of stacks tokens. That is dynamic, and you can look at it at that same endpoint that we just looked at. But as long as you meet that dynamic minimum, then all you have to do is make sure that your signer is running, and then you're going to call this stacks function. I have the source code here for anybody that's interested in reading through it for each of these functions. And then right now, this is just sort of an overview of the flow. There's a step-by-step guide for how to actually do these things down below that we'll cover next. But solo stackers really just need to make sure that their signer is running, and then they need to call this stacks function, and they need to pass in these parameters here. So it's the amount, the Bitcoin address they want to receive rewards at. Start burn height is it basically just tells the basically just says when you're going to start stacking. This is almost always best just to set this to like the current Bitcoin block height. Lock period is how many reward cycles you want to lock for. The signer key, this is the public key that your signer is using. So when we created that keychain in the first step with our signer, this is the public key of the signer. And then a signer signature is something that we'll go over in a second, but this is something that needs to be generated to prove ownership of that signer key. max amount, and then auth ID is a random string to make sure that this particular signer signature can't get reused. So solo stacking is pretty straightforward. It's just the one function, you need to pass in these parameters. And then the other thing you can do is you can extend, and this is another basic function call for you to, and then you just pass in how many cycles you want to extend. Function source code is here as well. Now the pool operator stacking flow is a little bit more complicated. And I think this is where we've had some people run into errors as well. So there's 3 steps that have to happen for the pool operator and or the delegated stacking flow. The first step is that the delegator initiates the delegation. So in this scenario, if I'm a delegator, that means that I'm somebody that I want to stack my stacks, but I don't have enough to meet the minimum for solo stacking, and I don't want to deal with running a signer. So what I'm going to do is I'm going to delegate my stacks to you as the pool operator and signer. So this is not something that you as the pool operator will do. This is something that stackers who want to delegate to you will initiate. And then what you do after that is for each of those stackers that have called this delegate stacks function and have used your address as the delegate to, this is your pool operator stacks address, so not your signer address, but they'll pass in your pool operator address as the delegate to. For each of those, you will then in turn call this delegate stacks function. And in that case, you will pass in the address of the person that delegated to you, how much they delegated, and then the Bitcoin address to receive those stacking rewards. Start burn height similar to the other one, and then the lock period is how many cycles they're locking for. And then the final step is after you've called this for each of the people delegating to you, once you have hit that dynamic minimum based on all of the delegated stacks, once you've hit that, then you can call this stack aggregation commit. Again, source code's laid out right here. And what this is going to do is this is actually going to take all of that delegated stacks, and this is the function that's actually going to stack it. And what you want to do here is you have your signer key and your signer signature. So this corresponds to what we set up in the how to run a signer step. This corresponds to the signer key, but you're going to call these functions, the stack aggregation commit and the delegate stacks functions. You're going to call these from your pool operator wallet, which is going to be separate from your signer wallet. And then you're going to pass in that same Bitcoin address to receive those rewards, the current reward cycle that you're operating in, and then the signer key that you generated at the beginning, and then the signer signature that we'll go over how to generate right now. And then we have a little bit more information here just about the distinction between these 2 roles. But that's the important thing to know, is that you have a pool operator wallet, which is going to be in charge of calling these stacking functions. And then you have a signer wallet, which is going to be in charge of operating the signer and calling transactions from the signer. But the manual actions that you'll have to perform, which are these stacking actions, those are going to be done using the pool operator address. And the pool operator can increase the amount committed as well. So the next part of this doc is the step-by-step stacking guide. The easiest way right now to perform all of these stacking operations is to use lock stacks. And so that's what this guide covers here. But the other way that you can do that is by using this stacking package that Hero created, if you would prefer to use JavaScript to perform some of these actions. So step 1, necessary prerequisite is to run a signer. We already went through that in the last document, so that part's done. The next thing you need to do is you need to generate a signer key signature. And so what this basically does is this proves that you actually are the owner of the signer public key that you're passing in when you generate these functions. So to do this in lockstacks, you're going to want to go to staging.lockstacks.com. And down here at the bottom is the signer key signature. And if you go here, you can generate the signature. Now, the important thing to pay attention to is you want to be authenticated with lockstacks, not with your pool operator wallet, but with your signer wallet. So when you generated that keychain for the signer at the beginning of the how to run a signer part of this, you got a mnemonic. And the easiest way to do this is to import that into Leather and then connect to Lockstacks using that authenticated wallet to generate this signer key signature. And a lot of this stuff is filled in for you already, but you can choose what reward cycle you want to be in. Most of the time, you're going to want to put in the next reward cycle if that's what you're intending to stack in. This is the Bitcoin address that you're going to use to receive the proof of transfer rewards. So this should be the Bitcoin address that corresponds to your signer, is what you should pass in here. And then the topic, this is what you're actually going to be doing. So in the context of the delegated stacking flow, what you're going to want to do is the stack aggregation commit, because this is the function that you're actually going to be calling when you pass in this signature. The maximum amount of stacks that can be locked, we can keep that as the default. And then the lock stacks UI generates a random number for us. So something else important to keep in mind that I've seen a couple people run into is that for duration, if you are running the aggregation commit function, this duration needs to be 1. If you're doing solo stacking, you can change this, but when you're running the stack aggregation commit, this needs to be 1. I think there's work being done on the lockstacks UI to enforce this at a UI level so that you don't accidentally change this because, okay, yeah, so there is a warning there already. So keep this at 1 if you're doing the stack aggregation commit function. Then you can generate signature. And what it's going to do here is just pull up a transaction for you to sign that, and the information gets popped up right here. I actually already did this earlier, and so I have this written down right here, but this is what it's going to look like. If you were to hit this copy button, it'll generate all of this. So then what you're going to do when you run the stack aggregation commit is you're going to take all this information. We're going to go to pool administration, and this is where we can find the admin functions like delegate stack stacks. So after somebody delegates to us, we can go in here and we'll call that based on the information that they pass to us. So their address, the amount of stacks, the start burn height, and then the Bitcoin address where you are receiving your rewards as the pool operator. So if we go back to here, pool administration, the other option here is stack aggregation commit. So when you go into here, again, the reward cycle that you want to be stacking in, the Bitcoin address that you want to receive rewards, this needs to be the same one as the one that you passed into the delegate stack stacks function and that you use to generate the signature. So those Bitcoin addresses need to be the same. And then you're going to paste in your public key that you got from right here. So that's this signer key field that you got from the interface we looked at before. Your signer signature, which you can get right here. I actually go ahead and pass all these in so I can show you what it'll look like. Public key here. Signature. Max amount. And then we actually need to get rid of these zeros on the end because this is going to be the max amount in microstacks and we want the max amount in stacks. And then the auth ID we also get from that copied information when we generated our signature. So now we can finalize cycle, and this is going to initiate that stack aggregation commit. So at this point, once this transaction confirms, now your signer is considered an actively registered signer. And so those stacking operations that we just went through, those are going to be the manual actions that you'll have to run each reward cycle in order to register your signer as a stacker and have it actually start performing those stacking operations. So those are the things that you'll need to do in that prepare phase or before that prepare phase that we were talking about. In order, then what's going to happen is because of all those transactions that we just made, when your signer pulls the contract that stores all that data, it's going to see itself there based on its public key, and it's going to go, okay, cool, I'm registered, time for me to start actually performing my signing duties. But if you don't run through those stacking operations, then it's never going to see that it's registered, and it's just going to sit there passively. It's not actually going to run as a signer. So that's it for the live workshop portion. So now we can go ahead and move into Q&A. If anybody that's here, Hank, Jesse, anybody heard anything you want to clarify or correct, go for it. Otherwise, we can jump into Q&A.
Nothing. I think you just did a great job. Yeah, appreciate it.
Yeah, great job, Kenny. Yeah, would love to open it up to the floor for folks that are watching. Any questions? If all that makes sense.
I have a few questions if I can start. A small technical one on the signer with the Docker container, you ran it with the parameter network equals host. Do you need to do the same for the node or that's not needed?
For me particularly, I did because I have two isolated Docker containers running on my Mac. So
Got
I
it.
do my setup, and if you need to run it on yours or not, it'll just depend on
Right.
what your setup looks like.
Right. That makes sense. Yeah, thanks for that. I was missing that, I believe.
Okay,
And then
cool.
I have a few more operational ones, maybe. I believe the length of proof of transfer cycles on testnet is the same as on mainnet today, or how does that work?
I think
No,
it's
it's 1 week. Yeah.
Okay.
The one on testnet is exactly half of the mainnet. So it's 1 week.
Both testnets are the primary, or sorry,
Yeah, both testnets, both Nakamoto
got it.
testnet and public testnet. And also, I have another question from the chat. So I think this is a good place to double click that if you have not yet started onboarding or set up on the Nakamoto testnet to use the mainline public testnet, that is the api.testnet.hero.sl. I think Hakai, if you're planning to rejoin the network, I would suggest like redirecting those efforts towards the mainline public testnet.
Awesome. Yeah,
Do you have
thanks.
that?
That's helpful. One last thing. Sorry about that. How do we get enough SDX to fill at least one slot? Because I believe, I don't know if the faucet returns a sufficient amount today. Or I may be wrong, I need to try again, but
Yeah, we have testnet stacks, Philip, that we can either send to you or delegate to you. And I get that goes for anyone here. If you need testnet stacks, we can help to make sure that you have that.
awesome. Amazing. Yeah, thanks. And then maybe for, yeah, one last one actually. The hard fork, is it planned for cycle A3 on mainnet? And if so, do all the SDX unlock then from proof of transfer, and then proof of transfer is like paused between quotes? So there's no yield for 2 POC cycles, or how will that operate on mainnet?
You can quickly relock your stacks. There's no period where stacking will be disabled. We are right about picking a block right now. So this should be somewhere around reward cycle 82, 83, and we'll send out the comms in the next couple of days related to this. We're targeting somewhere between the week of April 15th, so earlier that week. So that falls around cycle 82. So all the stacks will be unlocked when we move into 2.5 activation height, and you'll have to relock it, and you can do that immediately.
How much time will we have to do that approximately?
I think roughly 3 to 4 days you'll
Okay.
have before you'll have to relock.
And that's on the box 4 contract then?
Yeah.
Right. All right, and so those block heights, they will be communicated then in the next days or so. Cool.
Mm-hmm. Yeah.
Awesome. Yeah, that's all I had. Thanks a lot.
No worries.
Okay, well, from my side, I just want to ask you if there any way using the stacks JS SDK in order to generate the signature for the signer. There's a couple of examples for that, or the only way is using the UI that you were showing previously.
Yep. So you can use the Stacks.js SDK if you. I'm going to paste a link in the chat here. Hero has a whole page dedicated to the updates they've made to their products for Nakamoto. So if you go here, there's a section on Stacks.js that will provide code samples for how to generate that using the Stacks.js SDK.
Okay, yeah, great, because we need to sync our transaction offline. So we just going on also the only help using the Stacks SDK. So that's the reason that we cannot do it via online with the forms. So that's great. Thank you. Well, one last question, since nobody asking anymore. On all the full guy I read it, it seems, as you mentioned, quite simpler to do when we do solo staking. The integration with the signer is more really straightforward than we do, for example, for a pool or something like this. Is there any other consideration that is not in the guide that we should take care about that, or not?
For being a pool operator specifically?
Yeah, pool operator, and specifically, we are just going to do solo staking Stacks STX. Basically, that's our main goal. That's why I ask enough, of course, for the signature that we're going to use.
Yeah, so if you're solo stacking, then that section of the doc that we went through where you're calling that stacks function, that'll be the main stacking operation that you'll need to do, in addition to just extending that whenever you're ready to extend it. But as far as I know, Hank can correct me if I'm wrong, I don't think you need to take, there's no more manual action that a solo stacker needs to take other than calling that stacks function.
Great, that's a good one. Okay, well, I think that's all from my side now. In case I have more further question, I'm going to talk to you by the Slack channel, guys.
That's perfect. Thank you. And we do have one question here from Hakai. I'd like to know about the slashing parameters in stacks after the Nakamoto upgrade. Do you want to take that one, or maybe Sarala?
Yeah, unless I'm misunderstanding, there's no slashing in proof of transfer. So in lieu of slashing stacks tokens, instead it's just a lack of distribution of rewards. So if you don't perform your duty as a signer, you don't necessarily lose your stacks tokens, you just can't unlock them, and you don't generate the Bitcoin rewards from those stacks tokens. So it's a little bit different in proof of transfer than it is in something like proof of stake.
Yeah, and do either you or maybe Sarala recall exactly how many like missed transactions it would take before you start being penalized from the rewards?
I don't have that information offhand, but I can find that out for you. Hank, would you know?
Same answer. Yeah, sorry.
Okay, yeah, Hakai, we can get you some more specifics on that after the call.
Just to confirm, the reward cycles are 30 blocks on testnet. Are there 1 week?
30. Go ahead.
It's on the Nakamoto testnet. They're roughly 30 blocks, I think. It might be 40. But on the primary testnet, which we're hoping to get everyone to migrate over to, it's a 1 week or 1,000-ish blocks.
Cool, thanks.
Andre, there is a way that you can share the schedule that you show at the beginning in order just to sync up with you in order to do the proper deployment on our side. Thanks.
Yeah, definitely. And I'm not sure, is that chart in the docs yet? If not, we might want to add it. But I'll follow up and send that to you after this.
Yeah, I think it is, but let me double check. Yeah, it is. So if you go to the Nakamoto testnet page in the docs, there's a drop down that kind of lists all the different testnet environments. And that chart is right there in that. So it's on this page. Talking about the one where it outlines the differences between like Nakamoto primary and then when they're all moving to 2.5 and 3.0, that one that you showed at the beginning of the call.
Okay, let me see.
I have a question. Thanks a lot for the presentation. If we set up a signer on mainline testnet today and then delegate enough to it, like will we see the signer do anything or not until the Nakamoto is totally live?
You'll see it start to sign blocks at the start of the next reward cycle, I think. Saral, you can correct me if I'm wrong there, and then once Nakamoto activates, that process becomes consensus critical.
Yeah, you're right.
Okay, that's awesome. And then one more thing, the secrets that are configured, set up in the config files for signer and the node, specifically the private key and the block token, I think, or the auth password. Are either of those able to be set via like environment variables or even like command line arguments, or it's just in the config?
At the yeah, at the moment there's it's just on disk in the file, but definitely open to feedback on that. I mean, I understand the reasoning for sure.
Okay, cool. Yeah, good to know. Thank you.
Okay, anyone else? We have about 10 minutes left, but if there are no more questions, happy to end a little bit early. Kenny, I know that we had, we've talked about maybe doing a second workshop based on sort of what you covered today. Do you think that that would still be helpful, or maybe, for folks here, would that be helpful, or what do you think?
So I'm very open to feedback on what people feel like they need covered, but just from going through the process of creating the agenda for this workshop, one thing that I think would maybe be helpful for next week, just based on what I can anticipate people struggling with, is if we do more of a deep dive into the stacking contract and specifically looking at all of the different errors that people can run into. So for example, like when they're running these aggregation commit functions, there's a bunch of different errors that they can potentially get. And so what might be helpful is to kind of just go over a rundown of what each of those errors mean and basically what to do to fix it if they run into it. Because I anticipate that being the next friction point that people will run into is having these stacking transactions fail and not quite knowing why. And so I think if we can have, well, I'm already working on adding this to the docs, so that should be ready relatively soon, but maybe having a workshop going over that could be helpful. But again, open to any other opinions from anybody on that.
Yeah, how does that sound to folks? I'm seeing a couple of thumbs up, so
Like to see
think
that.
that
Yeah. I've had some issues myself, still not solved every single one of them, but that would be very helpful.
Cool. Okay. So yeah, we'll plan on that for then, and I'll get that added to the written version added to the docs over the next week or so too.
Yep, and I guess that second
Yeah.
workshop will be same time next Wednesday, same time next week. So I already sent out the link to that, but I can resend it so you guys have it again.
One more thing, if I may. If you could focus more on the JS library instead of this web UI wallets and stuff, because there are a lot of security concerns that we have with using these applications like the Ledger wallet, stuff like that. And it's way easier to big operators on like different chains to just reuse their tools for security, for signing transactions, stuff like this, when you can do it using the code, because it's easier to integrate. So if I have this request, if it's possible to focus more on the JS library next time. Thank you.
Well, yeah, and then I also know, I'll put another link in here real quick. Let me find it real quick. But Hero has a guide on integrating stacking, specifically using Stacks.js. And so if you combine the information in this guide with the updates that they made for Nakamoto that I linked up above, that should get you pretty far in using the Stacks.js package to integrate stacking. But yeah, that's good feedback for next time.
Yeah, Diego, are you just referring to the table that was shared at the beginning of this presentation?
I think he's specifically asking about the stacking. I think we can update the docs to be really specific on the auto unlock and relocking and the time that you have.
Hmm.
Okay.
Yeah, that's good feedback. right, everyone. Any last thoughts, comments, questions?
No, thanks for running this, Kenny. I know this was a lot of work. I really appreciate you.
Yeah, thanks everybody.
Okay, thanks everyone. We'll see you here next week. And thanks, Kenny, for running this.
Mhm.
See you, everybody.
Bye.